So today we're going to talk about arrays. And arrays are a way of representing information. And in fact, how to take information and somehow store it in a computer is one of the fundamental tasks in computer science. And so far, this task hasn't seemed very difficult. You know, you want a number, somehow you type 12, the computer is doing something with it. It's actually stored in something called binary that you'll run into or should read about at some point in your life. And similarly, if you type in 5.3, and that seems pretty easy. Actually, underneath there's a very complicated representation for that, stored in sort of a exponential notation kind of thing. Characters, we haven't really talked about those, but there's basically a table that matches up numbers with the actual characters. And true and false, basically there's zeros and ones at some point. These are primitive types, but you can imagine as we get into more complicated kinds of data, student records or images or videos or things like that, that perhaps there's more cleverness that can be applied to how to store that information as numbers in the computer. But we know a little bit, we have some more complicated representations already. We've talked about strings. So strings are collections of characters. And they're what we call objects. They have sort of this independent life, and you can ask them questions like, give me a character at position 3, or change the capitalization of this thing, or you can manipulate the data in some sort of meaningful way using methods. We've also used a scanner. Scanner is a little more mysterious what's going on underneath. We know we give some sort of text sequence, like a file or a string to it, and somehow it's doing some representation where it can pull out these tokens, these chunks of data one at a time, separated by white space. But our sense of what's going on internally there is a little more vague, I'd say. So we don't know much about the scanner. In fact, we don't really care that much, and that's one of the beautiful things about it, right? We just know we can ask for whether a token's there, and we can get a token, and that's all we want to do with it. And so that's all our understanding has to deal with, that kind of abstraction. All right, so we have very simple things, primitives, and we have slightly more complicated things, strings and scanners, and let's add another one on the sort of more complicated side, an array. So an array is a data structure, in other words, something that holds data, that holds a fixed number of values of the same type. And those are all important aspects of a Java array. So a fixed number, it holds values, and those values all have to be the same type. So that's the model you need to have in your brain of what an array does for you. Okay? So an array of 3 values can hold 3 ints, but it doesn't hold David and 5.3 and 12. These are different types. You can't do that. So don't be tempted to try to shove different kinds of information into an array. The items of the array are called the elements of the array, and if you're interested about which element we're talking about, we use an index number, similar to how we used it in a string. So in a string, we could pull out characters starting at index 0 and going up to length of the string minus 1. And in an array, we have the same kind of concept that the first element is really at index 0, and the second element is at index 1, and so on. So let's look at how to make an array in Java. So we give it some kind of type, like int or double or string or scanner or whatever we want here. So when I say element type, that's meant to be just like a generalization, right? Some sort of type that we already know about. And then we use these square brackets right after it. That indicates to the Java interpreter that we're trying to make an array of some kind here, not a single element, not a single value of that type. We give it a variable name as normal. And then we want to assign it some, so this declares the array, that variable, that type. And then we want to give it a new value. So we're going to say, make me a new array of a certain length. Okay? So these are all the important aspects, the square brackets here, the new, and the length at the end. So as a more concrete example, if I wanted to make an array of integers, I would say, make me an int array. That's one way to kind of read that little section there, right? It's not just a plain int, it's an int array. Give it the variable name, my array, and again, that's my choice, what I can call it, values, items, integers, whatever I want to call it, my array. And that is enough to declare the variable. And then I'm assigning it a new array of size 3. Okay? Question?
The size of the array, can you do you have to declare it in the beginning, or can you leave it empty and not have it declare its size? Because you could fill it with anyone.
So I can make an int array myArray semicolon here, and that just declares the variable. You can't use it until I give it an object that it knows about of some size, and it's a set size at that point. So I can delay this aspect.
Can you change the size as you?
So you can't change the size of a Java array. You can reassign it another array of a different size, and I'll talk about that distinction in a little bit here. Okay, so this is basically it. The same kind of form we've been using for all our variables. Declare it, initialize it, and it has just a little different syntax and the other stuff. You just have to kind of get used to that a little bit. Any other questions about what you're seeing on that sort of example down there? Like, do the parts of that make sense to you? Questions? All right, we'll look at some more here. When I make an array like this, you can kind of think of it, again, as creating a sequence of spaces to hold values. And in this case, we made an int array, so the values are going to be all integers. And again, we access the item that we're interested in one at a time by using an index value. So if I wanted to look at that 55, I would ask for the item at index 1. All right? If I wanted this one, I'd ask for the item at index 3. So we use the index to get to the parts of the array. Right? We can't just sort of say, give me the whole thing, or give me the 75. We're going to instead say, tell me which one is stored at the position at index 3, and it tells us that. So when you first create an array, it creates a bunch of spaces to hold values. It doesn't know what should go in those values, necessarily. And so by default, it will put zeros in there for you. All right? So that's a nice thing. Java likes to be helpful. There are other languages, when you make an array, it doesn't initialize to any values. You have just sort of garbage values in there, like 10 million, 65, or negative 1 million, or something like that. And so that's sort of confusing when you create an array and print it out, and it's filled with all sorts of weird values. But Java will set them all to 0. If I wanted to give an element a new value, I can assign it. So here's the syntax for assigning a value to a specific location in an array. So if I've created my array here, and at some point I made a new int array of size 5, then I can say at index 2 here, give it this value 3.2. Okay, so it looks here for the index 2 and puts in the value there. Notice, once I've used this sort of square bracket notation with an index in there, that acts just like a normal int variable in some sense. I can ask what value is stored in there, I can assign a value inside there, but instead of a different name for it, like value at 2 or something like that, I just refer to it through that number. So it doesn't have a distinct name, variable name. It's just part of the array. But once you get that little square bracket in there, it kind of acts like an individual int variable in some sense. So let's look at some code. Okay, so let's, just to be a little different, I guess, let's make a double array. So this is going to hold doubles, values with decimal parts to them. And I'll still call this my array. And I am going to assign it a new array of size 3, let's say. Okay, so at this point, running this code, my array will hold 3 values, all filled with 0 at this point. And I can change those values. So I can assign a value to the first location, index 0, like that. I can add something to the index 1 location. And I can add something to the last location. Now, so again, normally on the left-hand side of assignment, we're used to seeing a variable name there. In this case, we're seeing the array variable name, but we're getting a specific item or specific location using this indexing operation. In other words, give me the location, the element at this spot. If I wanted to look at one of those values, I can use the same kind of notation. So my array 0 is array 0. So notice, just like a variable name, if I had num or something, normally I would say num equals 1.2, and I could print out the value in num. And again, it would know how to evaluate that variable to see what value is stored inside it. In this case, I'm using this indexing operation, the square bracket notation, to assign a value to one location in the array. And here, I'm using the square bracket notation to pull out one value in the array, right? So they just act like double variables at this point. But again, without a special name, they just have the array name in combination with that indexing operation. So if I were to run this, it says my array is 1.2, and that is the value that I put in there, right? Okay, so questions on that? Just use that square bracket notation to make each element act like an individual little double variable, and you can assign values to it, and you can evaluate it. And those are the two things we used to do all the time with variables. Questions? Okay, now it's a little frustrating having to print out things like one at a time when I wanted to sort of get an understanding of the entire array. And I could make a loop or something like that and print it out that way. But there are tools in Java to help us print out an array, so I'm going to, well, let's do a string here. String, array, string, not very exciting. So in the arrays class, there is a static method called toString, and I can pass my array in there. All right, and I kind of thought I'd have to import something. Okay, import a Java util arrays. So I'm using this method, static method, toString, and it takes in an array and makes a nice text representation of it that we can print out to the screen. Okay, so I can then print this out. My array and array string. Now I could have put this call here, arrays to string my array, directly here, right? And it would evaluate that to a string, and then it would concatenate that and print it all out. I wanted to break it into two lines, really to emphasize that this method here is making a string out of the array, because it's a string type, and then I'm printing out that string. Okay. So if I were to run this, we had our old value, looking at it one at a time, and here, this is the string representation of my array, and it's kind of nice. I put square brackets around it. That's a pretty standard notation for like the elements in a string, in an array, and a comma between each element, and so you can kind of look at the whole thing all at once. So it's a nice way to debug your arrays, to print them out a lot like that. Okay. So again, this is the kind of thing you got to learn. Like, oh, I want to print this thing out. How do I do it? Oh, you got to use this toString thing, and eventually it will be the form you want. Questions? Yeah.
So are arrays objects like strings, where we can have methods?
Arrays are objects like strings. That
So
they have things they can do, and we'll talk about it next lecture a little bit more.
That happens to not be. That's a different method to make it into a string.
So again, for some reason, sometimes methods are attached to the object, and those are the non-static form that we'll be talking about at some point, how to make those. And they know about the innards of that object. I would have thought in some ways this thing would be a good thing to attach to the object because you're trying to print the object itself. And there are reasons they did it this way, obviously, but this is a static method that takes in an object and does some action on it. In this case, makes a string.
There's a class of array.
There's a class called arrays.
That do other things to arrays that they didn't want attached to the array.
They didn't want to make one method of the object for some reason. Yeah. Until we see enough of those, we can't see why you'd want to split it off into two parts, but that's what they did right now. Okay. Now it's sort of painful to create and initialize an array like this because it takes a lot of lines, right? And so let's say we had more items to put in there. That would be a big long chunk of code, all which looks sort of vaguely the same. And it's easy to make mistakes, and it's sort of annoying to have so many lines and stuff. So there are shorthand ways of initializing an array. So let's look at one of those. Let's see, what do I want to do here? So let's do an int one. Int array, my values, my vals. And I can initialize it with this little initializer thing. Oops, integers. And if I were to print that out, my vals, and here I'm going to directly call that arrays to string on my vals. Maybe that, oops, something's okay, so if I run this, it knows that my vals has 1, 2, 5, 10, and that's because I initialized it with this little curly brace form here like this. Okay, so you are allowed to kind of, instead of saying my vals equals new, int array size 4, and then a separate line, my vals 0 equals 1, my vals 1 equals 2, my vals 2 equals 5, my vals 3 equals 10. You can do it all in one line. So, and of course you can kind of see how the Java interpreter could probably figure out what to do with this, right? It counts the number of elements that are in here, 4 of them, and says, okay, I need an array of length 4. And so it creates for you an array of length 4 and sticks those values in there one at a time for you.
Are all arrays static in their size, or is there like a dynamic array?
Okay, so the question, yeah. So this is sort of a more primitive kind of array, this Java array, and it's static in its size, it can't change. Soon we'll talk about something called an array list, where you can expand it and shrink it as you desire. Now you're not allowed to say my vals equals 4, 5, 6, 7, and if I try to run this, it complains and says, it basically, array constants can only be used in initializers, basically when you're first initializing that array. So you can't use this as a shorthand way of like overwriting a bunch of values all at once, okay? Now you can do another form, which kind of confuses the issue a little bit. So I am allowed to say my vals equals new int array, and I'm not giving it a size, but I am going to give it some values in this little curly brace form. So 5, 6, 7, 8. And if I print out my vals after this, it changes it to that form. Okay? So it's a little confusing that we're going to yell at you, don't use this initializer form except for once at the beginning, right? And then you're like, well, and then we're like, well, you can sort of use something similar later. And so, but it's different. This one is actually creating a new array object for you, and it happens to stuff these values in there when it creates it. This form is trying to say, well, really the same sort of thing. It's not clear to me why they won't let you do it. Good question.
Can arrays be other objects such as, say, scanners?
So you can make an array of scanners. You can make an array of arrays if you want. We'll talk about that at some point. But they can hold anything you want, but it has to be the same type in each element, right? That's the key here. So another question? Or, yeah.
So if an integer array is like automatically filled with zeros, would a string array just automatically be filled with empty string?
Yeah, it's like whatever the sort of the small thing is in that item. I'm trying to remember how it determines that. There's some mechanism that knows how to do that. Question? Can you change what? One? The way to change an individual value would be by accessing it through its index, like here, and giving it a new value, basically, right? So this is really the more common form. You're not typically saying, here, store a bunch of numbers, and then like, oh, forget all those, store another bunch of numbers. It's more like you're saying, store a bunch of numbers and do some work on them, And in the process of doing work on it, you're changing individual ones like one at a time or something like that. So if you want to change one, access it through this little index thing. If for some reason you want like a whole new array, do it this way. Now let's try something else here. Let's put that there. Notice this is a different length than this, right? And I said you can't change the length of an array. Well, again, this is making an array, and this is making another array. And so first myvals is looking at this array, and now myvals is looking at this whole new array here. They're different arrays. So you can store different arrays in a variable, but you can't change the length of the array once it's made. Right? So it's a little bit of a distinction there. So let's look a little bit about sort of what that means, I guess. So let's go back to slides for a second here. Yeah.
On that note, did it overwrite the old myvals?
No, I'll show something that maybe give you the right model for that. It's a little tricky what's going on there, really. All right, so you can't reassign it, but you can make either just a new empty array or use an initializer. So we've talked a little bit about primitives versus objects. And so a primitive, again, that variable is sort of directly looking at that value. So int num3, num and 3 are sort of tightly tied together. If I make an array, I'm really making a separate variable that references an object that's somewhere else in the computer, right? So they're almost two separate kinds of things. And this is a very important model to get kind of straight in your head. So if I were to just do a print line on vals instead of this arrays to string thing, let's see what that does, first of all. So we've been doing all this kind of stuff, and I'm going to here just, instead of this fancy method, the more typical thing is why don't I just print my vals and print out my vals, right? So just say I want to print this thing. So before we're using this toString to convert it to some form, and here I'm just saying print out what this variable is. All right, so my vals is holding this value, which is interesting, right? This is a reference. This says I'm looking at an object that's somewhere in memory, and in fact it's looking at some, okay. This is basically some sort of memory address. It's not exactly a memory address because Java doesn't live exactly on your computer hardware. But in your computer, you know, everything is stored basically in the RAM memory, right? Random access memory. And there are just a bunch of addresses. 1,000. I'm going to just skip forward by little chunks just for not totally accurate reasons, but let's see, 8, 9, A, B, C. And in here are stored some kinds of values, like 5, or a character, or something like that, right? So this thing here is saying somewhere at one of these addresses is my array. And an array is going to be a sequence of numbers, 1, 2, 5, or something like that, right? Stored in sort of consecutive locations in memory. And this is saying where the beginning of that chunk of memory is. Okay, so we're not trying to get too much into like actual computer systems type stuff here, but I want to give you some vague idea as to how this is working. Now, if you're really looking carefully here, you can see that there's 1, 2, 3, 4, 5, 6, 7, 8 of these characters. And so there's 8 characters in that reference. What kind of things are those characters there? Like, what is each digit there representing here, do you think? It looks sort of like a number, right? But what's wrong with that number? It's got an A in it, right? And that's because it uses something called hex, hexadecimal. And hexadecimal is a number system that goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then keeps going. It has an A digit, and a B digit, and a C digit, and a D digit, and an F digit. And these are worth like 11, 12, 13, or actually 10, I'm sorry. 10, 11, 12, 13, 14, 15. Text is this is a base 16 number. So you have to go back and read about, if you're curious about this, you can go back and read about, we use a base 10 number system, digits 0 through 9. Computers use basically binary, has two digits, 0 and 1. And the shorthand form of binary is hexadecimal, which is base 16, and has digits that go up to 0 to 15, and it's all powers of 16 for the numbers. Okay, so I don't want to, again, that's not part of this course, just getting a little background information. Go read about binary if you want to, go read about hexadecimal. It will aid you if you haven't learned about this stuff already.
So when you're creating the new array on the old one, does it get rid of the old one?
Well, yeah, let me show you. I'm working up to that, okay? Let me show you. So there's 8 of these digits. Each one of these each hex digit takes 4 bits. This is a 32-bit reference, so it's looking at 32 2 to the 32 locations in memory. And you hear people talking about 32-bit systems and 64-bit systems, and that's related to that kind of thing. So let's not dwell on that, though. But that's sort of what's going on there. That mysterious thing has some meaning, basically. It's not just random garbage, basically. Okay, so references are really sort of some sort of memory address. It's not a direct match again, but it's essentially a memory address of some kind. Now, how does this work on the computer? So when you declare a variable, it keeps a little table somewhere that says, okay, I know about num, I know it's an integer, and I know where it's stored in the computer, like memory address 1000. And if you're making variables, they're basically part of the memory called the stack. And the stack grows every time you enter a new scope and add variables, it adds to the end of the stack, and every time you leave scope, it deletes it off the stack. So this stack is kind of going, I know about num, I know about val, I know about name, and then it enters another, like a function, a method or something, and says, I know about x, I know about I know about this. It leaves scope, and it says, pop, 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 I don't need to know about those anymore. And then it calls another one and adds those. And so the stack is kind of growing and shrinking as your program executes, okay? Now, objects like strings and now arrays are created on the heap. And the heap are still part of computer memory, but instead of adding to the end and shrinking them, they basically add wherever there's free space. And so they don't live in any sort of organized way. So how do you get rid of them? The stack stuff you get rid of when you leave scope. It says, I know I made all these in these scope, and I'm going to get rid of them when I leave that scope. On the heap, it just says, okay, make it here, and then every once in a while it asks, hey, does anyone still like referencing me as a variable? Like, are there any variables that know about me? And if they're not, it says, I can't be accessed through any variable in this program, so if I can't be reached, I'm not of any use anymore, and it deletes itself during garbage, what's called garbage collection. All right, so let's see an example of this a little bit. So here's some code. Here's a little table of keeping track of the variables we know about, and here's some addresses in computer memory that I didn't fill out with values for some reason. I meant to have numbers on them. Okay, so we start executing, and memory magically gets a bunch of addresses. So we say, okay, we're declaring a variable num, and it's a type int, and it stores a value 3. So in this table, it says we need a variable num. It's of this type, and we're going to put it on the stack, the first location that's available to us. So in address 1000 in computer memory, there's this value 3 stored. And essentially, every time you use num in your program, it says, they say like, if you say system out print line num, it says, okay, where am I stored? Here. What value is stored in that memory? 3. So that's where it gets the 3 from. And if you want to change it, it says, okay, where should I put this new value? I should put it in location 1000 here, and it'll change, if you say num equals 4, that becomes a 4 there, right? So there's a very direct connection between the name of the variable and where it's stored. But you still have to hop through this thinking about this computer address. We can't really access this in Java. We can't see where in memory these primitive types are actually stored, okay? In other languages, we can see where they are, like in C and C++, they give you access to it, which is both dangerous and useful sometimes, okay? So Java's trying to protect us from ourselves in this case. So that's the easy case, building a primitive. Add it in this table, put it on the stack. Now this next line, we're making an array. So it says, okay, I have a variable called numArray. It is of an array type, an int with a little square brackets. And I'm going to put that in on the stack because this variable numArray is still built in some scope, right? It appears in the scope and goes away when we're done with the scope. So what value should be stored here? Well, the value should be stored here is where this thing, this object that we're going to build, lives. So when we see this new int array, it says, make me an array somewhere in the heap. It's not on the stack, so it adds space for 2 integers here on the heap part. And it says, this object lives starting at address 1020, and I'm going to store that address here as the value of this variable here. Okay, so it's a 2-step process. This thing holds a value. The memory address it's at holds a value as well, and that address says where this object lives in memory. All right. Now again, Java tries to kind of pretend this isn't really happening and wants you to work sort of directly with numArray as it's kind of like just the object itself in some sense. But underneath it has this whole double jump. It says this variable has to live somewhere on the stack, and the value it holds is the location of the array in the heap. Okay? And this number here is what we saw when we printed out what was in myval, or whatever thing we printed out, right? When we used the toString, it went and actually found these values and made a string out of all those values and let us look at it. But when I printed out myval directly, it printed out that number for us. Questions? It takes a while to get used to this model. Don't despair, you know, if you're like, what's going on here? So this is the correct way to think about what's going on with objects and these variables that reference them.
I know this is simplified, but it shows that it's referencing 1020. How does it know to go to 1024 as well? Like,
so yeah, this is a little bit of a simpler model, but basically somewhere your operating system knows about where there's available memory, and it knows that there's some holes in the heap big enough to hold 2 spaces, and it just picks the first one of those and kind of says, put them consecutively so we can access them efficiently, essentially. All right.
Is it just 0 as like a default?
So again, when you make an array without an initializing curly brace thing, it does put 0 in there by default. All right, so then we are kind of done with this chunk of code. We're leaving scope. When we leave scope, the variables that were created in that scope go away. So we don't know about num or numArray anymore. They get deleted off the stack. And again, there's some little trickiness that knows like everything that was in this one scope goes from 1,000 to 1,010, and so take that whole chunk out all at once kind of deal. This doesn't necessarily go away. It's an independent object that lives on the heap. Now at some point, there's this garbage collection phase, and it goes through all these and says, hey, are you being referenced by anything? And there's nothing up here that references memory location 1020 anymore. So the code has no way of getting to that data anymore, right? It's still alive somewhere, but we have no way of getting into that information. And so it just says, you can't be used by any program, so pull yourself out of the heap and delete yourself. So it also goes away during this garbage collection phase. Okay? So there's a lot of little subtleties going on underneath, but you're going to run into problems in your code if you don't sort of get this basic mechanism down. Let's try something that demonstrates why this is important. So in my code, I have myvals, which equals 5, 6, 7, 8, 20. And I'm going to make a new int array reference. Again, these variables I create here are really the references to the objects, right? They're not the objects themselves. So I'm going to call it copyvals. And I'm going to assign it myvals. All right? So I'm taking myvals and I'm assigning it to copyvals. And if I were to print out copyvals, see that it holds the same values as my vals. So here's copy vals, and here's my vals, 5, 6, 7, 8, 20, right? So we made that assignment nicely. Now I'm going to say my vals at location, at index 0, equals -10. I want to change it, right? So let's print out, I don't want that. Let's print out my vals. See what's in it. So here's copy vals, here's my vals. I successfully changed the 0 index of that. And now, just for fun, let's also print out copy vals again. Okay? So I'm assigning my vals to copy vals, I'm printing out copy vals, I'm changing my vals, print out my vals, and print out copy vals again. So what do you notice here? What's maybe surprising about this?
Change copy vals as well.
So what?
My vals also changed.
Well, we changed my vals on purpose. What else is different here?
Copy vals, copy.
Yeah, the copy vals somehow changed as well, right? Copy vals changed from 5 to 10 in that first location. So that would be confusing if you were trying to debug this program, right? Because it's like, I didn't want copy vals to change, I made a copy of it. So why is this happening? What do you think?
Because the array is just storing the memory addresses which you changed.
So the variables are storing the references to a single array object. And when I copied it, I just said, use that same reference. So let's look at whether that seems true or not. So here, I'm printing out my vals. And this is printing out that memory address sort of referencey kind of dealio. And then I also want to print out copy vals in the same form. And if I were to run this, what do you notice about the reference for my vals and copy vals? They're the same number, right? So they're referencing the same object in memory, and any changes you make to that object are really changing the exact same object underneath. So you can think about this like this picture. I made vals. It references some array object. When I said make an other array reference and assign it vals, it takes that value stored in vals, which was that memory location, and assigns it to other. And all of a sudden, these both are referencing the exact same object. So if I say other1 equals 5, it changes that to 5. If I say vals 1 equals 5, that also changes the same one. But both are referencing the same object, and so they're not independent entities anymore. Okay? Now, I would say you would have to be pretty deliberate in some ways to make this mistake. Like, why am I doing this kind of action? There is a separate copy array method you can use to copy what's called a deep copy, to copy the actual values instead of copying just the reference. When you do this kind of assignment, it's called a shallow copy. It's not really copying all the values so they're independent of each other. It's just saying, let's both reference the same object here. Now, the place I think this really becomes important is when we start making methods that use arrays. So I'm going to make a public static int. First of all, let's just use add, and I'm going to take in an array. Now notice here, I'm declaring this parameter as an int array type, but I'm not giving it a value, right? This is a parameter. We pass information to this method. We don't give it information here. Question?
So if you made a shallow copy and then you change the original, does that make a new slot in memory for that modified?
So if you change the original by changing one of the elements, it's still just changing the value inside the.
So the shallow copy, is that
No, those are the same reference. They're holding the same reference, right? So they're both referencing the exact same object in memory. And any changes to that one will change the other one in some sense. But they're not two objects here. This is one object, and they're both looking at that same object.
Even if we change the size?
If you change the size, like say, if you said myvals equals new int array of size 6, that's now referencing a separate object. And so the copy would still point to, let's just bring that real quick, I guess, here. So if I have myvals referencing some array of size 3, and I have copy vals assigned to that same one, and then I were to say myvals equals new int array of size 2 or something, it would make something of size 2. This would now reference that array. This one would still reference the original array. Both those objects would still stay alive during garbage collection because something is referencing them. But these are now independent objects. Yeah.
But if you didn't make it a new array, would the same go like that?
So if you didn't make a new array and you did what instead?
And you said like myvals number 2 is something else.
Yeah. So you said myvals 0, 1, 2. 2 is 5. It would change the value stored in there.
So then copy would be a different array.
No, it's still pointing to this array. It's still pointing to that array.
Okay.
Right?
Yeah, I see what you're saying.
Yeah. And that's what we saw here. This minus 10 showed up in both arrays, even though we only changed it in one through one of them. Okay. All right, let me kind of quickly here. So we made a method called add, and I'm just going to return the array value at index 0 plus the array at index 1. And if I call that add myvals, then let's look at what happens here. So we have, get a little more light on this. All right, so if we have myvals pointing this thing, I call add with myvals. The method add takes in a parameter called R for array. Basically, there's going to be a new reference R array that also points to the same object, right? So when I pass an array as an argument to a method, I'm really passing the reference to that array, and the parameter takes on that reference and is referencing that same object. So again, it's not a separate array being passed to this add method. It is a shallow copy of the array. So when I say add together 0 and 1, I'm really adding together these two values here and pulling those out of the original array. Now, if I make another method, public static void change, what do I want to call this thing? Yeah, I call it change. All right, cool. And I want to take in an int array reference, and I change array 1 to be some new value. What does that do for us? So let's print out myvals again here. So we're going to add some values together. And that doesn't change anything. And then I'm going to call this change on myvals. And I want to print out what's stored in there. Okay, so if I run this, I had myvals, negative 10, 6, 7, 8, 20. I called change on myvals, and it goes in here and accesses the first index in this, what looks like a variable R array, but is also a shallow copy of myvals. So it changed myvals index 1 location to -3. All right, so we can change the value of the array inside a method. Now that's different from what we're used to. So normally, if we call a method and pass an argument to it, and it has a parameter to accept that argument, then we start running, we make it a num that has a value of 1. We call add 1 with num, and the value 1 gets passed to this parameter, x, and the value is passed to it, right? The 1 is shared. Those are not the same variables in memory. I do my operation on x equals x plus 1. It changes that to a 2. And then when I leave scope, x goes away, and num is still 1. So here I'm passing a primitive to a method. I'm doing something to that parameter, but the changes in it do not propagate outside of the method because I'm still passing a value, the value 1 here, and initializing x with that value 1. Now, if I do something with an array instead, I have vals that references an array. I pass that vals to my method where there's a new r parameter. The value stored in vals, which is this memory location, gets copied to the r parameter. And that means they're both looking at the same object, right? Because that is the same number as this number. That value got passed, but it's not the full array. It's just a reference to that array. So these are now looking at the same thing. When I change array 0 in that method, it changes the value stored in that object. And when I leave the method, this reference goes away. This one still exists. It's looking at this object, but the array itself has changed. All right? So that's an important distinction. Primitives, you pass by value, and it doesn't affect the argument. References, I'm not changing the value stored in the reference. It's still the same number, so it doesn't break that rule. But I can change the things that it references, the object inside of it. All right, so I'm allowed to make changes to arrays inside of methods. I can't change the array. I can't initialize it to a new array with a new value. That doesn't persist. But I can say, hey, we're both referencing the same thing, and if I make a change in the method, it's going to also change the original array, because they're the same object. So you need to pay a lot of attention. We have methods that have array parameters, because you can't guarantee that nothing is happening to that array. Maybe they're changing it with all new values, right? And so you need to be very aware of what that method is supposed to be doing for you. All right, so we'll be digging into this a little bit more. It's a lot to comprehend, I think, at once, but it's the right way to think about arrays and references. You need to get it solid how that works.